here is to find the volume of the solid of revolution by revolving this region about the x-axis and to find the most convenient method for doing that. Of course, if we're going to use the shell method, we want our typical shells to be parallel to the axis of revolution. So you might picture something like that. If we were going to use the washer method, we would want the typical rectangle to be perpendicular to the axis of revolution. So if we're going to use the shell method, we already have an expression for this horizontal distance, which is the height of the shell, in terms of x, or in terms of y, right here. This x distance is y times the quantity 5 minus y. So there's setting up the definite integral using the shell method, where we're multiplying the height of the shell by the average radius, which is the distance from the axis of revolution to the center of a shell, which is why we get y squared here. Now, if you were going to use the washer method, we would have to get this y distance, outer radius, inner radius, in terms of x, which would, here's what I did here to show you what's involved. Y equals, this is the quadratic formula. So y in terms of x is this mess right here, which I've written as h of x and q of x. So h of x is actually the top half of this parabola, and q of x is the bottom half of this parabola. And now it looks like we do get the same answer, pi times the definite integral from 0 to 6.25 of outer radius squared minus inner radius squared. If I had to do this manually, I don't think I'd want to square h of x and q of x and subtract them. And so definitely this is more convenient than the washer method. Okay, and I'll leave it to you to find the antiderivative and get an answer in terms of pi, but hopefully that explains why the shell method is more convenient than the washer method. There you go. Hope that helped. If you have any questions, post a comment.